Thanks for coming, appreciate it. I know there's been a lot of data science related talks, a lot of machine learning talks this week, and it seems like they've all been packed. So it seems like this market, this group is really hungry for the content. I wanted to make sure everybody was aware, if in case you didn't actually read the abstract, that this is an overview of the world of data science, concepts, frameworks, tooling, trends. If you're looking for a step-by-step how-to on how to do data science, this is not one of those. I'm not going to show you how to build an AI from scratch. But if you're coming from the perspective I was, where say you're a developer or BA or some other field, and you're interested in potentially moving this direction, that's where my research started, is I started looking into what should I study, what should I learn about. And the more I did, the more overwhelmed I got by the whole thing. And the more I thought, there might be other people who could benefit from some of what I've gathered. So that's what this is. And before we start, are there any data scientists in the room? 1, 2? Okay, so y'all need to leave and make room for other people. No, I'm just kidding, you can stay. I actually really enjoy when there are data scientists in the room, because as I've said, this is not like my primary forte. I'm a developer by trade. So if there's anything along the way that you think would be valuable to the rest of the people, or for those of you who aren't data scientists, but maybe you just know something, feel free to speak up. This is a small room, so we can make it a conversation. So the main reason why I feel like this is so applicable and why I'm seeing so many people attend these is this trending we're seeing, and we'll talk about the specifics of the trend. But I think when Google's chief economist says, like, this is going to be the big thing, the statistics, the data, it's worth stopping and taking note. In fact, the growth we're seeing we're not talking about 10, 20 years out. Like, we're already in the midst of it. And I don't want to use the term exponential, because we might have some statisticians in here who'd call me out. But it's growing by leaps and bounds. In fact, well, this is just an interesting quote. What I was trying to get to was actually the shortage of data scientists. I believe somebody told me that for every 8 data scientists out there right now, there are 10 jobs. So it's like the development world right now, where we're lacking the talent, but there's a trick here, especially for those of you who are the hackers, the people who put together solutions with technology. There's a really great opportunity for you to get plugged in. We'll talk about that. But first, I wanted to completely overwhelm you by the world of data science and all the tools and frameworks and platforms that there are. This is a diagram by Matt Turk. He puts out one every year. In fact, I'll show you the one from 2016. And we'll go back to the 2017 one, but you might notice it doesn't seem quite as crowded. We've got a fair bit of infrastructure analytics. It's kind of balanced between all the different sections. And what you'll notice as we move between one and the other is the distribution between the two. We've still got about the same proportion of analytics and infrastructure, but the application side has blown up. We've shifted more in that direction. The infrastructure has grown. I mean, even though the proportion seemed about the same, we've got way more platforms than we did before. And these are only the main ones. Obviously, there are a lot more outliers. Analytics, the same thing. A lot more ways to analyze your data to produce some sort of insight. But the applications realm, as the industry becomes more mature, you have to have the platforms and you have to have the tools to analyze the data. But as we get to where we've established more what kind of problems we need to solve on a regular basis and make it easier to do so, that's where we start seeing that shift towards applications. And that's where it gets a little bit easier for people who aren't as technical in this specific field to pick it up and start working with it, to actually take a data set, point an application at it, say, here's kind of what I'm looking for, and start getting some results pretty immediately. So I guess part of what I'm trying to do, besides overwhelm you to begin with, so we can dig into some of this, is to say we are seeing a transition to things becoming a little easier for more entry-level people in this field. And first thing I want to talk about is the buzzword that has fallen out of favor, but it's an important concept to get right from the beginning, is what's involved in big data. Most people think of volume, right? The name is big data, it's big, right? In fact, you might even say it's humongous data, like that's where we're going with it. And it's true, we're seeing this crazy growth in the amount of data that's generated, partially from all the mobile apps, the mobile devices, the IoT devices, like your refrigerator is probably now generating data. But that's only one aspect of it. You can have big data just from variety, just from the type of data. If you have ever done photo analysis, you have an app, or Facebook does the facial recognition, that's unstructured data, and you can't really analyze that without tools, right? You can't, it's hard to take a library of photos and say, these are the photos with this person in it without some sort of analysis tool. And different types of unstructured data, I've got a list here, but think anything that isn't tabular or isn't in the same format from one set to another. So now we have two different things that could define what big data is. We have to consider a third now that the world is accelerating. I mentioned the IoT devices. How quickly that data comes across could also make a big difference. Maybe you only have a record with 10 pieces of data in it. It's not big, but you get one of those every second. All of a sudden, you really need some specific tooling to do analysis on it and maybe to funnel that down into something usable. And we'll talk a little bit more about some aspects of that. Some examples, you've seen how Twitter streams, or you can't keep up with it if you've got as many people on your list as I do. I work for a bank, so the stock exchange is a great example from my perspective of not only fast data, but which we'll talk about some of these terms, but also how the value of data declines over time potentially. So it's really valuable the moment that it happens, but then every moment that goes by, it's a little bit less valuable. So you have to have tooling to take advantage of that value. And so we have all three of these, and I would say any one of these directions or two of these directions could push you towards big data. So what kind of skills would it take to analyze the data? I like diagrams, I like visualizations. I figure like that's what we're talking about is visualizing data. So let's talk about how these overlap, do a Venn diagram. So I think most people here are coming from the technical side, or maybe you're a BA with some technical chops. And that's a skill that we often take for granted because we're surrounded by hackers. We're surrounded by people who played with computers, who geek out about this stuff. So the idea that you can set up your own workstation and install these apps and set up a database and do ETL between databases, it becomes kind of old hat after a while, but these are skills that the majority of the public don't have. Traditionally, when you overlap this with stats, that's where machine learning comes in, right? You know how to set up a platform, you know how to get something established, and you've got some idea of how to look at data, and you put those together and the machine can kind of spit out some results. Anybody have a different opinion on that? Because machine learning is not my forte, and there's been several talks on that, so maybe if anybody has a different perspective on that. But what happens in our industry usually is you have the hacking expertise, you might not have a lot of statistical knowledge, but you know a domain, like you're familiar with an industry, or you become familiar with it as part of your job. And that's where we start seeing the software development, where those overlap. And statistics and subject matter expertise, that's where scientists, they know what they're looking at, they know how to analyze it. And where all three of these overlap, we have data science. Make sense? Anybody disagree? Like, could there be something we might be missing in this Venn diagram? Usually when somebody asks that, there might be. Anybody have an idea? So this is the diagram you'll most commonly see on the internet, but I did find one that got me thinking about social sciences, or the idea of like, how does this data fit with our world? How is it generated? How are the results going to be used? What's the impact? The context is important, not just the domain expertise of the data, like how it fits in the world that data was generated, but how it relates to the larger world around us. And so that was what I call awareness of the domain. And so I think we'll come back to this as we touch on other topics, but if you think about self-driving cars, for instance, they gather a lot of data, and they use that data to improve themselves, but they still work in a world where people do things that you wouldn't expect, right? Some guy slams on his brakes right in front of you, even though there's nobody on the road, but he just spazzed out and he hit the brake, right? So the context matters, is what I'm getting at. So we've talked about big data and data science just as a concept. So let's talk about how those might overlap. Oh, I just threw a funny comic strip in here. So the first thing I wanted to talk about is some buzzwords having to do with both of these worlds. So you probably heard the term data lake. It's become a lot more common term in the last year or two. The idea here is that it's just a place to store a bunch of data. It's really what it comes down to is we know we're generating data. We might not have it in the right format or even know what we're going to do with it later, but we need somewhere to put it, right? So we throw it in a lake. And as you do with lakes, you mine things out of it, right? So data mining is just trying to get value out of the data, trying to get insight. Unstructured data, we touched on that. And it's particularly important because we're just so used to working with like tabular data and SQL databases. And it feels overwhelming, the concept of unstructured data, but it's much more common in this world. It's something that you have to become a lot more comfortable with. Dark data, the idea that you don't have insight into the data, you might not know it exists, you might not be using it effectively, that's why it's dark. I heard somebody mention dark developers the other day, which I hadn't heard that term, but apparently that means like the 9 to 5 developers that, not you, the people who don't come to these things, who don't come out to the meetups, those are apparently dark developers. So same concept. It's not a racist thing. So fast data, we touched on that. The value declines over time. A lot of times it's very rapidly delivered. Edge analytics, my interpretation of the concept is think of IoT devices, they're on the edge of the internet. They're bringing you data from the unknown. They're going where no man has gone before. And then predictive analytics is the fun stuff, right? We're trying to tell the future based on the past. We're using some data sets to figure out what might happen. You didn't have a baby yesterday, you have a baby today, you might have 12 babies by next week, right? That's sort of predictive analytics. And then of course we want to visualize it. We got to be able to do something with this. And oftentimes, especially with as early as we are, data analysis has been around for a while, but being able to process these huge amounts of data that we're generating is still relatively new. So a lot of times we need to let leadership know what we're seeing before they can even know what direction to take it, where to do more analysis or what kind of solution. So visualization, I guess I'm just saying, shouldn't be undervalued. I thought I'd take a second to break down the terminology of the actual word data science. And when you think about it, it makes a lot of sense. You start with a hypothesis like a scientist does. You say, here's what I'm thinking might be true, might not be true, or what I'm looking to prove or disprove. And then you look at the data and see if it supports that or if it shows you something different, right? Very scientific approach. There was a great definition in a Birchworks study, and I've got several things from this Birchworks study, and all the references to this stuff is in my slides, so those will be available online, or are already available online. But while this is a very cohesive definition, and I'm not going to read it off to you, but I really prefer the one that I found from Josh Wills on Twitter, which is basically that a data scientist is a statistician who's better at development than other statisticians, or a developer who's better at statistics than other developers. It's a marriage of those two worlds is what I'm trying to get at. Any questions, by the way? I feel like I'm blazing through this so we can get to the good stuff, but I don't want to gloss over anything that somebody wants to delve into more deeply. So I thought now that we've got out of the way the idea of the definitions, the concepts, we're all on the same page about what we're talking about, maybe it'd be good to talk about what skills are involved in doing the job. Data acquisition is something that I'm going to keep harping on. Well, the cleaning and transforming, but acquisition too, because we might not like writing SSIS packages or doing ETL work, but getting data from one place to another is really time consuming. Oftentimes it's what data scientists will often consider grunt work. And that and the cleaning and transformation, which is not generally the technical side, you don't have to know all the algorithms and the statistics to do that, takes up about 80% of the time of what data scientists do right now. I see a couple heads nodding in the room. I guess those are the data scientists. And that's where this opportunity that I'm talking about lies. And then, of course, we have to do the analysis, which a lot of times the analysis is less magical and complicated than you think. I think that I've been told there's maybe around 5 approaches towards solving a problem, different types of algorithms that are used for most business problems. We're not reinventing the wheel at this point, generally. There's a lot of tools and approaches out there already. And then the programming automation is this other sweet spot for us, is if you think of the traditional PhD data scientists, they really focused on the statistics and what it means to get good data and how to process it. They probably didn't learn how to implement it, how to take the results that you find from that analysis and change the website so that it works better, or write an app that does something productive for the business based on this outcome. So being able to actually take that insight and understand it in depth and then implement it as well is hugely powerful, especially for the smaller companies. So on a daily basis, what this might look like is, first of all, figuring out what that dark data is, what data is available to the business, what they might do with it, collaborating with leadership. There's a lot of opportunity to educate in this field. A lot of companies, they have places to store their data, but that might not be the place that they need to have it to work with it. So you might want to, for instance, want to do in-memory processing to be able to do faster analysis. And so even though they already have a data store, you might need to set up some infrastructure to start working with it. And I was talking about finding the data and identifying what they have, also understanding what kind of pain points the business is facing might be beneficial. Things that they never previously considered there was a solution to, because they didn't have the insight needed to even identify what type of solution they needed. You might be able to prescribe that. Yeah?
So when you come into a job like this, what are your parameters? What are you trying to do for the company? How do you know to look for those things that the company doesn't know?
Well, I've traditionally come from a consulting perspective, and not doing data science work, but just in general. So my thought is I'm usually brought in on a project where they know what needs to be done. But then while I'm there, I find all these other things that when I look at other companies and other ways they're doing things that are better, I can make suggestions. So I guess from a analysis perspective, it would probably be where are our competitors excelling, and we might not know how to get there, but our data could allow us to figure out a path.
Like a lot of accidental discovery almost.
Yeah, I think that we don't know what's there until we start looking at it, certainly. And that's part of that initial exploration. But I guess I'm also keying in on that domain expertise of understanding the business well enough to apply it, right? And it's just a magical combination when you get all those perspectives in one person or in one team, which we'll touch on that too, that you don't have to be everything. A lot of times teams are made up of components of people who have various specialties. So don't freak out feeling like we're just covering way too much. This is too big of a step, because oftentimes you can just be a piece of this puzzle. Yeah, thanks for the question or comment. I put in here research new techniques, but I also wanted to make sure that everybody was clear that new techniques are generally not the answer to most problems. There's established approaches. And in fact, we'll talk about some languages and platforms where there are thousands of packages already available to solve a lot of these problems. And then the always funny, does anybody love ETL? Am I bad-mouthing ETL to somebody who's like, oh, I hate this guy now? No, nobody loves ETL. Extract, transform, and load, by the way, if anybody who's not familiar with that term. Implement algorithms, that's what we're talking about, things that were already created. And then, of course, doing something with it, with the outcome. To help encourage you and not feel like you're already starting from way behind, while, again, data analysis is not a new thing, this particular field is relatively young still. Most of the people in this field have less than 5 years of experience. In fact, it looks like about half, or actually more than half, have less than 10. And these are some of the Birchworks graphs, by the way. So I have a link to the study where you can read about the data that's behind it.
Is that in thousands, or what's the left mark?
Apparently I cut that out. I would recommend checking out the study to find that out. For me, it was more just looking at the ratios, the breakdown. But that's a good question. Yeah, I should add that. It's also true of the education level. You can see over the last several years, the percentage of PhDs in the field has declined dramatically as more and more entry-level and mid-level talent comes in. I also thought it was interesting, since I've given this talk from one coast to the other, to look at the breakdown of where the focus lies. And San Francisco is by far considered the mecca, as far as I've seen, of data science. The West Coast has certainly jumped on this, but maybe we can make a comeback down here in the southeastern edge. It's certainly a lot of interest here, and I expect a lot of demand. I also like to look at the breakdown of where these people are coming from. You would make sense that mostly we're talking about statisticians in this field, which is true. It's still the majority. But between 2016 and 2017, oh, that's a different one. Yeah, so it's just this. And then, in addition to that, from 2016 and 2017, we saw a shift away from the, marketing a lot of times adopts a lot of these things early because they're chomping at the bit to micro-optimize their approaches. And we're seeing a shift away from that towards other industries. In particular, consulting is becoming a lot more common in data science. So it's becoming a lot more regular for companies to reach out to you as an individual to come in and do some work for them, as opposed to feeling like they have to hire a data scientist, like one person to do the work. So when we're actually looking at doing the work, usually we're trying to solve one of 5 questions, or generally one of 5. The idea of classification, we're talking about, is this something or is this something else? You've probably seen the cloud services that you can put an image in and it'll tell you if it's a dog or not, or what kind of animal it is, or not really that exciting, but a lot of times very useful for business. Anomaly detection. I was just talking to somebody who their credit card got flagged. Anybody have their credit card get like a fraud alert while they were here? Yeah, that's anomaly detection, so welcome to the world of data science. Regression, predicting temperature would be a good example of regression problems. Anybody who uses Netflix and gets the recommendations, that's a good example of clustering. And I mentioned self-driving cars earlier, the reinforcement learning of based on my past experience, how should I be acting? And in order to do this, I did some analysis in the education sector of the kind of tooling that was used. And the reason for that is because in scholarly articles, you can very easily identify when a technology is used for a certain purpose. It's very clearly stated. Whereas in the general business world, if I want to look at, say, the popularity of Python, it's difficult for me to figure out if it's being used for data science or just building a website or what the purpose is. So we'll look at some data about the academia, but also in the process, we need to understand that their focus is different. They tend to use more expensive tools a lot of times, ones that require a higher learning curve, and a lot of these aren't as popular in business. But I think it's important to understand that this is where a lot of the PhDs, for instance, are coming from. This is their roots. So SPSS, SAS, Stata, MATLAB, you might recognize some of those from college. They're not nearly as common in business, and we'll look at some numbers from the business world as well. But you can notice that R, which is still a major tool in business as well, is second on that tool breakdown. And I don't have a metric for if this is in thousands or whatever either. But again, relative popularity. And as far as trending in those scholarly articles, and this was from 2014 to 2015, but the trends have generally continued that Python has shot up in popularity. I think actually 2014 to 2015 was when it really took off in this world. And R as well, and then those others that I was talking about, the SPSS, SAS, have declined. I was actually surprised that they considered Hadoop in decline, but it's still quite healthy, and we'll touch on Hadoop as well. And you might think that you have to learn some new big platform that's specialized towards data analysis to start getting into this work, but if you've ever used Excel, which I imagine every person in this room has, you've used a data analysis tool. You don't have to have, remember, we don't have to have big data sets to have big data, right? So you could have thousands of records in Excel and do data science with it. And then obviously the SQL platforms are extremely popular as well. I wanted to give a little bit of a visual overview of some of the languages or development technologies. And the iconography here, you might recognize the green open source icon, and then the $ with the line through it is free. You can go online and download it and use it. The double red icon, double red $, is that these are pricey and oftentimes not used by smaller businesses, maybe more academic. That's what the hat's supposed to mean too, is that this might have a higher learning curve. That's generally considered the case between R and Python, for instance, and we'll talk more about those. And these are Julia, Kafka, and Storm are more recent. I don't know as much about those, but I had several people in some of my talks say that like those should be included as well. So if anybody has anything to throw in about those, this is as much as I'm going to talk about them.
Julia went 1.0 this week.
What's that?
Julia went 1.0.
Julia went 1.0, so it's officially out. Okay, excellent, thanks.
But
Yeah.
they say the packages are not up to date yet, so you might, the 1.0 is actually a breaking deal for most of the packages.
Okay, so if you decide if you decide to check out Julia, don't get 1.0 because you can't do all the things with it, right? What's that?
Wait a month.
Wait a month. All right. Yeah, in the back.
Even though SaaS is expensive to own, it's free to learn at SAS.com.
Oh, excellent.
Use SAS Studio for free. SAS is having a lot of problems with R and Python being free open source.
Mm-hmm.
So they're feeling the pinch from competition, just so you know.
So the open technology platforms have put a lot of pressure on some of the traditional expensive ones to innovate.
Dr. Goodnight realizes they're there. And so you open up SAS and you go to SAS and you use SAS Studio for free. And you make SAS and advanced SAS certification for free.
Okay, so the tooling and the education and all around SaaS are free. It's just if you actually want to use it like in production,
Yeah.
that's where you pay the big bucks.
Yeah, it's kind of like the drug dealer model for
Right. Just a taste of SaaS. Got it. Great. I'm loving the comments. Anybody else have anything to add about these?
What's the frowny face one?
I think that was indicating that people generally had a negative reaction. I don't know anybody who's ever said to me, I love MATLAB. Like, it's my favorite thing in the world. Yeah. All right. So I wanted to focus a little bit on R and Python. Yeah, as you noticed, that the SAS has a certain niche, being expensive. So I figured most of y'all are going to be looking at the R and Python. So over time, at least as of 2016, Python had really hit the industry hard. It became a major contender. And as you'd expect, it mostly took over in the technology sector. The people who oftentimes were familiar with Python, because if you're not familiar, you can build applications with Python. It's not just for data analysis. So it's much more general use. So corporate and telecom and surprisingly retail were some of the highest adopters. Of course, the people with the higher degrees still prefer generally the R, which is, we'll touch on it more specifically, but it's based on a statistical language called S. So that's where its roots are, is data analysis. So a bit heavier, but more specialized towards that purpose. And I just thought it was interesting that in this particular study, which is the Birchworks study, they broke out the idea of data scientists versus data analysts, saying we're not talking about the same thing here. And data analysts, well, they don't like Python as much, I guess. They want the more statistically focused tools. They're not having to hack at the data as much, I guess.
That, 'cause
Yeah.
I've seen that chart. So the big difference for me is that R, it depends on how close you're trying to make it to actually implementing. If you're planning on building something that then is going to go into software, you kind of have to do Python. But if you're doing it just to learn about it and describe it, then R is perfect. So that chart makes total sense.
Yeah, and that fits with the fact that Python is a programming language. You can build things with it, whereas R is really more about the analysis. So if you want to take it a step further and implement that, you're going to have to take the results and do something else with them. I'm also restating this because I'm mic'd, so the mic might not pick you up, so I'm trying to restate.
So in that chart, how do they separate the data scientists? So if you did anything predictive, no longer data scientists?
That's probably a bigger question. That could probably be a whole session, how you differentiate between the different jobs, and there's probably a debate to be had there. I don't remember in the Birchworks study how they break that out, but it's a good question.
So I just wonder if they consider all the grunt work data people than data scientists, and then all people doing the analytics. Not.
Yeah, I would say that they would say people who only do the analysis, they're only like writing reports basically, they would not be considered data scientists, right? The deeper munging of the data, which munging is like getting it ready to work with, right? We'll actually talk more about that too. And again, between the analysis and the data science, they broke out the SAS, R, and Python, and I think this is pretty much showing us the same thing as the last one. So anybody here use R? Awesome. People who use R love R, right? Everybody who uses it says like R is awesome because it is super powerful. And there's tons, over 9,000 extension packages, probably over 10,000 by now because this slide hasn't been updated in a couple months. It's free. There's R Studio. R is both the name of the language and the development environment that you can use to develop it. And you can do R development in other platforms as well, other toolings as well. Visual Studio has R support. I think SQL Server has R support as of 2015? 16? Yeah.
Teradata actually has R and Teradata as well.
What has R in Teradata?
Teradata has R. You run R packages within Teradata.
Oh, so Teradata has R packages now. So the industry in general is adding R support to their platforms and tooling. So
You can run it in Hadoop, Hive.
you can use R in Hive. We'll touch on Hive and Hadoop in that world. So it's a great choice. Keep in mind it is based on a statistical language and it's not as general use. So it's fairly specific to the purpose, but that makes it very powerful. And this is open source, big community. Yeah?
Just a curiosity question, because I'm not familiar with Python, but I'm hearing that it has lots of packages. I know in the JavaScript world, lots of packages and support for them. What is it specifically about Python that makes it such a great language for this? Or was it just sort of like first mover advantage, like it started being used for this and therefore it's used for this?
Well, that's a great transition over to talking about Python. Unfortunately, I don't have enough expertise in Python to feel confident in answering that, but I bet you there's somebody in this room who might.
All the PhDs were using it.
PhDs are using Python?
Yeah, they put out papers and then the developers were able to pick up on it.
Okay.
Yeah.
Yeah, that's our
Readability?
It's just super easy to learn. It's like, as they said, it's described, Python is like operating pseudocode and just running it. So a lot of people know.
So readability and the syntax being simple and easy to consume and read, that's a big deal.
A lot of the stuff in the back is just C libraries, and it has really good interfaces to interact with all those C libraries, so it wraps everything.
So all the code that was written in C that's useful in Python can be implemented. Yeah, excellent. Well, I learned something too. Thanks for the question. And this is also, by the way, you can do this in Visual Studio. I'm pretty sure that that SQL Server has Python support too. I should add that to the slides. I think that was as of 2015. And there's tons of packages for that one as well. I don't even know the number. I think it's more than 10,000. But the idea of the packages is if you want to try to accomplish something with it, here's a framework or toolkit that you can use to do that. So before you try to build something from scratch, obviously search, see if it's out there. Anybody have anything to add about Python in particular? I'm going to try to encourage developers who don't necessarily have a deep statistical experience to check out Python first. That seems to be the general consensus, is that it's easier to pick up. It's more similar to the development languages you know already. But if you're
It's still fast enough, like it's not as fast as Java, but it doesn't have the developer overhead of like a type system like Java. So it's a lot easier for somebody who doesn't have a lot of programming experience to pick up, like a statistician, and learn. It also has the language itself has some features about it that make it easier to maintain over the long term.
Okay, so the maintenance might be a little bit easier. It might not get as unwieldy as your solution grows.
No pointers.
No pointers, that's always a good thing, yeah, for anybody who did old C programming. So let's talk for a moment about Hadoop. Anybody here do Hadoop development or tinkered with it? Obviously the data scientists are familiar. It's a really popular platform, and it, correct me if I'm wrong, but my impression is that it really pioneered the whole MapReduce approach, which if you're not familiar with MapReduce, if you've written a Lambda statement before or passed a function into a function, that's kind of what we're talking about, is we're passing how to do something in as a parameter, which Hadoop lets us distribute that by saying, here's how we're going to work with this data. It sends that out across nodes and allows you to spread that compute out across more hardware. So HDFS is the file system, Hadoop file system, that lets you span multiple computers with this data. And then MapReduce allows you to do this batch processing where you can divide up the work. There's also PIG is a Pig Latin, stands for Pig Latin programming languages. It's where you might write the MapReduce programs. Hive, otherwise HiveQL language, allows you to summarize and do analysis queries. I've got a couple notes here because I don't do Hadoop either. HBase is a NoSQL database, so that's where you store your unstructured data. And Storm allows you to do streaming processing, so that the fast data that we were talking about, being able to work with that. And then Spark lets you load it in memory, so you can work with it even quicker. And there's over 150 different projects for Hadoop, so there's tons of functionality out there. These are just some of the major ones that came up when I kept looking at the topic. Anybody else have any that people should check out? Yeah.
If you're a Hadoop shop and you have SAS, your learning curve can be minimal. If you have SAS, because you use proc SQL, you write SQL and use either the Hive or Impala engine. So again, if you're SAS, you just write proc SQL just like you write on Hadoop.
He's really selling SAS. So if you want to use Hadoop, SAS makes it easier because you can write SQL against it. Okay.
What's the stock price of SAS?
Yeah.
For Storm and Spark, they, in my experience, they both approach the same problem from different angles. Storm is more geared for streaming, and Spark started off as like batch processing. Since then, they seem to be kind of converging on like a micro batch strategy to kind of take over, kind of compete against one another. And there's another Apache project called Flink that is really...
Flink. How do you spell Flink?
F-L-I-N-K.
Oh, just like it sounds. Okay. I thought it might be a PH or something.
They have some really good features for setting up analytics on the stream, like setting windows on your stream to do like averaging and different analytics based on like a set batch of data coming in. So
Excellent. I can't repeat all that for the mic, but that was great insight.
You should put Kafka next to Storm.
Oh, Kafka next to Storm. Yeah, that makes sense.
Kafka's the messaging bus that goes into Storm.
Anybody familiar with messaging bus? The idea that like you put something out there like this data has changed or this is a new record, and then things that are interested in it can tune into that and know about it when it happens. So Kafka and Storm, that's the pair that allows you to do that. Cool. So that's as much as we were going to talk about Hadoop, but I think it's important to have that on your radar. So we'll take a moment and talk about like what it looks like to wrangle data. They call it munging as well. So you can imagine if you have a data set of people who are pregnant, right? And you've got this missing data, because very rarely is our data as complete or accurate as we'd like. There are several ways we can handle this, right? We could say, well, if the record's not complete, then we just won't use that data. Well, in this case, that would leave us with one record. That's not going to allow us to do much analysis. We can also infer some things, right? Like we might know that if you're female, you might be pregnant, but if you're male, it's pretty unlikely. Or if you're 2 years old. So we can start figuring out some of these things and maybe only discard some of the records. So this is a very simplistic perspective on the idea, and I've actually got some more slides with some notes on different approaches and techniques. But really, I just wanted to get the thought in your head that it's not some magical, mystical process. Like a lot of it's just logic and applying where did this data come from? What's the purpose of it? What's the context? And getting it to a point where now a computer can more effectively utilize it. Anybody want to add anything? Because this is a big topic, and I used to throw up a bunch of bullets of different approaches and techniques, but there wasn't really a whole lot of benefit to just throwing that up there. You can research it on your own time. Okay, we'll jump ahead then. I did want to mention some visualization tools, because a lot of times when we throw up this list, people in the room will have other visualization tools they use or love. But D3.js, we probably have some people in the room who've already used that. And you're not necessarily doing data science work, but you've got to visualize some data somehow, right? Any other frameworks besides the ones that are up here? Tableau is extremely popular with business analysts. It's very easy to use, low barrier to entry. Yeah?
Telerik.
Telerik? You mean just the controls in general?
You can use contributors if you really wanted to. Very glutton for punishment.
Yeah, so there's some control sets out there like Kendo or Infragistics.
I like Word Cloud 2. Word Cloud 2, make it the shape anything you want. PGN.
And for creating word clouds. So like where you have the,
Shaped like a car or rocket ship.
oh, okay. So if you want to do some creative, like pretty visualizations where you take words related to a topic and you make them shaped like an image, word clouds, a good tool for that. Yeah, that might be good for presentations.
I like using Kibana.
Kibana? Is there anything in particular that would make somebody want to check it out?
You can throw data into Elasticsearch as unstructured data and then make sense of it in Kibana.
So Elasticsearch is a really popular approach to working with data, and Kibana will let you visualize that. Excellent. Was somebody back?
And Power BI.
Power BI, yeah. Excellent.
I was going to say I don't like it with Power BI, and the nice thing on that one is it uses much of the query or structured language that Excel was using with Power Pivot. So it's the analysts who have been doing all this stuff and have these flat files and reports on their hard drive. They can start to do things on a web environment.
So the Power BI tool is really targeted at people who they're used to the Office suite, they're used to working with things in Excel, and this just gives them more power to do deeper analysis. Yeah, and you can do Power BI development on the cloud. It used to be pretty expensive as the credits that it used, but they're really pushing, at least Microsoft, and I'm sure Amazon too, are really pushing these cloud data analysis tools, so you could probably find some free credits for that. Yeah.
Our shiny dashboards are really nice.
Our
Shiny.
shiny
Yeah, shiny.
dashboards. All right. Thanks for the suggestions, and I've got them on video so I can add them.
ggviz is kind of dead.
ggviz is dead. So
ggplot is based on ggplot2 in R.
okay.
Actually, and that's really great.
So ignore the second one, ggviz, and go straight to ggplot.
But ggplot2 in R.
ggplot2 in R.
Is that's Python.
Gotcha. I see. So this is the Python ggplot, and ggplot2 is in R.
Yep.
So as far as ggplot is concerned, R is the way to go. Got it.
The only other one I see missing is matplotlib.
Matplotlib.
Yeah, it's a Python package that a lot of the Google eggheads use.
Okay, so Google is very popular to use matplotlib. Got it. Wow, this has been some great visualization tool, and this is the fun stuff, right? That you can find data sets already that have been groomed out there, like data.gov is a great place to go for grab some data sets and start using some of these right away.
Similar to D3, there's another library called 3JS, like spelled out,
Mm-hmm.
and that's it's for like 3D visualizations in JavaScript. So D3 is really good for 2D visualizations and charts. 3JS is if you need to add an extra command depending on what sort of data you're working with.
So D3 for 2D, 3DJS?
It's just 3JS.
3JS for 3D visualization.
Yeah.
Yeah, and I also do a presentation on augmented reality, mixed reality devices like the HoloLens, and we're starting to see a lot more 3D visualization now that you can actually work with it in the space you're in. Cool. I'm not going to go very deep into machine learning, but I did want to touch on the topic, mostly to demystify it some, to make it feel less like it's something from science fiction, although I guess it kind of is. So you've got three different components of machine learning generally. You've got a set of classifiers or a language that the computer uses to understand the data, like what it's looking at. Then it has to evaluate it, which you have some objective or some scoring function that you're using to figure out like how close is this data to what I'm looking for. And then of course you have to optimize that. The highest scoring classifiers are used, and that's about the extent of my machine learning experience. But I have some visualizations that kind of help you understand like what that might look like from this is supervised machine learning, a visualization of that, and specifically a decision tree model. So you're already familiar with this concept, is like yes or no, does it go this way or that way? And keep doing that down as far as you need to classify. Another approach that I found a neat visualization for unsupervised machine learning is the Gaussian mixture model, which I couldn't even begin to tell you how to do this, but I thought it was really cool to see how it start isolating the clusters of data that belong together. Anybody who has more experience in machine learning, there was whole talks on it, so don't go into your talk, but if anybody has any comments they want to add real quick.
The word you're looking for is K-means, usually when a lot of these are based.
K-means?
K-means.
Excellent.
Just Google that.
So if you're interested in machine learning, Google K-means. I also thought it was really cool to include just because it's a neat idea. If you hear GANs, people talk about GANs, that's generalized adversarial networks, or adversarial networks. And the idea here is that you've got this machine learning algorithm that, say, knows how to classify things, like, is this a dog, right? And then you might have another algorithm that says, that can create photos of dogs. And so then they start battling it out. Like, this one creates a photo of a dog, and this one tries to figure out if it is, and see if it's right, and this one's constantly trying to trick the other one, and they can both get better in the process. So if you think of like some science fiction story where you have two AIs and they're getting smarter by fighting each other, that's the world we live in now.
Those never end well. Seen the movie.
Let's hope it ends differently for us. And we're also, yeah?
It's kind of along the vein of visualization, but Khan Academy has a series of videos on information theory, and because it's all videos, it's all kind of setting a story and explaining the information theory, like data entropy, which is backing of a lot of these algorithms, and it makes it a lot more approachable. Like, it helped me out kind of understanding some of those concepts.
So for this specifically, Khan Academy is a great source. I've got some learning resource links at the end, and I think Khan Academy is in there. So if you want to check it out, there's a link at the end.
It's on YouTube. It's good.
Great. Yeah, there's a lot of great resources on YouTube. Harvard has some videos on YouTube on data science as well.
The guy that created this neural network wrote a book about it called Grokking Deep Learning.
Mm-hmm.
It's a really good resource as well.
So a good book, Grokking Deep Learning. Excellent. We're also seeing a shift away from like a very focused AI. So for instance, if anybody's had a Kinect in their home, like a Microsoft Xbox Kinect, that has machine learning built in because it can't know how to interpret every body shape and every position, every environment. So you have to do the calibration, right, where it has you do like a YMCA poses and figure out what you look like. And that's so it can then basically write the code effectively that it then uses to work. But that's a very specific purpose. It couldn't tell you like what grocery item to add to your shopping list, right? But we're seeing a shift away from those very specialized AIs towards more general. So I just wanted to throw that out there as like a trend we're seeing and something to keep an eye on. I also mentioned that if you don't want to have to set up entire environments, you can jump out to the cloud and start working with a lot of this stuff. I'd recommend checking out BizSpark. Is a Microsoft program that'll like get you free MSDN and Azure credits if you have a small business, which you individually can be a small business, independent consultant. So if you're just working on tinkering with something, like that could theoretically qualify you for the BizSpark program. So I'd Google that and check it out.
It's called Microsoft for Startups now.
Oh, they've renamed it. Microsoft for Startups, thank you. Did they also rename DreamSpark? Maybe it's Microsoft for Education. But DreamSpark is the one for students. So if you're in school, DreamSpark is designed to give you this sort of tooling and Azure credit when you're in it. Basically, unless you're making a ton of money, they want to give you the tools and give you access to it. I did have something else here on machine learning. Just a couple of the most common concepts. I was told that k-nearest neighbors and random forest can be used for most problems in business for machine learning. I'm seeing a little bit of nodding, so I guess that's right. And then there's a ton of Python libraries out there that can help with this. We did talk about being able to visualize and use the results you're getting out of all this analysis, and I won't beat that dead horse too much, but consider that it's not just about creating a report like we normally think of an analyst doing. It's oftentimes going a step beyond and figuring out what the critical thinking of like what's important out of this result and how do I best convey that to my audience. So not to overlook that. I did want to touch briefly on what kind of companies you might target depending on your approach towards the world of data science. I found this neat chart that they broke down the different types of companies into 4 categories. You might not be able to read it, but it says that a data scientist is a data analyst who lives in San Francisco, right? So just because you do a data analysis and you're in the right place, you're a data scientist. But these sort of companies, the idea here is that they focus mostly on the basic tooling of the work and how to visualize that data. They're just doing reporting, basically, right? And some basic analysis. And so we'll call those a type A data scientists. The second category is please wrangle our data. So we're still looking at, the basic tools are important all across the board, but now we're focused more on the software engineering, the hacking skills. We need somebody to be able to figure out where the data is, bring it into a common data source, maybe get it prepared to where these tools can start using it. That's where the data munging row comes in handy. And so this is a sweet spot, I think, for developers. These are the type of profile company you'd probably be looking at. Then we have, we are data, data is us. I think of Google when I think of this, right? This is their main product, this is what they do. They already know, they already have the platform set up, they already have the data going into the right places probably. They're really focused on how can we optimize this? What kind of statistical analysis can we do? And how can we use machine learning and AI to get us even further? This is probably not where everybody's going to start out, but keep in mind, these teams may still need somebody to take some of that data munging work off their hands. So that depending on the opportunity and the team might be a good place to plug in. And then finally, we have reasonably sized non-data companies who are data-driven. And this is a lot of the companies I've done consulting for. Like, think large tire and auto manufacturers, right? They have a traditional business model. They might not be the most modern in the way that they use their data. They might not even be aware of a lot of the value that exists in their data. So a more of a generalist would be really useful here. Somebody who has a basic understanding of statistics, machine learning, but they still need a lot of this data munging to bring the data into the common platforms and the ability to communicate concepts to leadership, to say, here's the direction we need to go, here's where we need to put more effort, that sort of thing. Anybody have any thoughts on this or questions, comments? Y'all been really awesome with interaction. So. How much time do we have left? Oh, just a few minutes. That's good, because we're nearing the end. So I mentioned that we had some training resources, and there's a ton more than this, and we won't take too much time with shouting those out, but I did want to particularly stress boot camps, because in Nashville, National Software School that's where I'm from, is a nonprofit boot camp, and they're just graduating their first data science cohort, and I've been really impressed with what they have covered, the breadth and also the depth they've hit. And I would encourage anybody to check out their local boot camps, because you may not have seen marketing about it, you may not know it exists, but it might be something they're working on putting together, and you can maybe even be part of that first cohort. Also, YouTube is an excellent place for sources. Anybody have any big ones they want to shout out real quick? Yeah.
SQL Saturday is a real big one here.
Mm-hmm.
Universities.
So SQL Saturday was traditionally more the structured data traditional approach group, but they're having to retool and grow as well. So
That's where I learned about R&R Studio 4 years ago.
yeah. So anywhere where the traditional data specialists, data professionals go is starting to have a lot more of that content.
So Wintellect and Pluralsight look at.
Wintellect is a great source for online videos, and Pluralsight too. Excellent.
We have a meetup group called Big Data Jacks for data scientists in Jacksonville. There's a lot of meetup groups as well.
Oh, perfect. Yeah, any local resources I wouldn't know about them to mention. So Data Jacks? Big Data Jacks. Great.
Subreddits are pretty good if you're learning something to ask questions and just track, because people post up videos.
Mm-hmm.
And in Philly, which is where I'm from, there's a really good Slack channel. So there might be good Discord or Slack groups that you can hop in on and just listen to the conversations happening
Mm-hmm.
and start to absorb different things.
So if you like the conversational approach, check out Reddits and Slacks. Also, if you're competitive and you really need something to compete with to get you excited about it, Kaggle is not actually as much a learning resource as a competition. Say Netflix will put out a challenge to optimize their clustering algorithm, and the people who win this, they're micro optimizing, down to the 10th or 100th of a percent difference in results. So we're not talking about real world sort of like, usually 80-90% value is amazing for business. But if you thrive on that competition, that's another great way to get plugged in and excited.
That is there's bounties sometimes associated with those competitions.
Yeah, you can win money, although there are teams who do that just for a living now, right?
The Siraj Raval on YouTube.
Saranj Raval, that's an individual.
He did the Udacity course for deep learning, and he owns a YouTube channel and a Slack channel for deep learning.
Okay.
Those challenges. So he's a real good one to get people pumped about deep learning.
Great, and they give you a place to plug in and chat as well.
Ask someone in your company, preferably with a higher title than you, who will look amazing. You reach out and ask for advice on how to do any of this stuff.
And that's a great point, is I mentioned the profiles of companies you might look at thinking like you might make a move, but there's probably a need in your existing company or an effort going on, and you might have something to contribute or offer those people while you're in your current position. So you could get plugged in and learn as you go. Yeah, great. I did find a pretty neat graphic from Swami Chandrasekaran. I don't necessarily agree with the order or everything that's on here. It's kind of interesting to me, some of the really basic stuff that's far along the learning path. But if you're the type of person who needs some direction, like what's the next thing I should look at, these are general categories of different types of topics broken down into even bigger categories like machine learning and visualization and data munging. So I've got a link to this in the slides as well. And what's that? Oh yeah, it does look like a metro map. And that's all I've got. The slides are available at .netdude.net, and I'm sure we'll make them available through the conference website. We have 3 minutes. Any questions? Yeah. Go ahead.
You said that high demand is, there's going to be high demand for data scientists in particular, but is there any sense of that, like mathematicians or statisticians that are going to be in higher demand than others?
So this is just my personal perspective, and it's not based on industry analysis, but I feel like that's going to become less important. Like, so the people who do it are going to be very valuable, don't get me wrong, but I feel like the majority of the people who are needed in business are going to be the ones to use the tools, not the ones to build the tools, right? So the deeper understanding of variable calculus and these heavier concepts don't seem to me like what's going to be the most in demand in the job market. Would y'all agree generally?
Yeah, my experience is like if you're starting in a place that doesn't have a lot of knowledge, the heavy math statisticians are useful because they can understand the data and find the trends and know what algorithms apply to the data. But as like the market kind of matures, you're going to see more and more use cases. You're going to be able to find more articles of people describing for this use case, use this algorithm. And once that happens, the demand for specific like math scientists is going to kind of diminish a little bit.
Yeah, I don't know about y'all, but most of the apps I built are just CRUD apps. They're just things to put data in the system or to pull data out of the system. Business needs are usually pretty simple and pretty common, like the same type of solution over and over. So I wouldn't overthink the level of expertise that's needed to get your foot in the door at least. Yeah. Any other thoughts or questions? Well, thanks. Y'all been a great audience. All right.